So basically, our agenda is to make sure that we are able to clear the certifications. Okay.
Exactly.
Yes. And
So
knowledge also.
exactly, sir. Exactly. Once we clear the certificate, it's quite obvious that we get a good knowledge of Azure as well. So initially, what we'll do, we'll cover that is Microsoft Azure Fundamentals, which having a certificate, there's AZ 900, right? So once this fundamental is clear, then we move to DP 203, that is a certification for data engineer, right? So likewise, we'll go because before understanding the data engineering, we have to understand the basic fundamentals of Azure as well as somewhat Azure terminologies, right? So in our first lecture, this is our lecture first. In the first lecture, our objective is first to understand what is cloud computing. And second, we are going to understand some concepts that security, privacy, compliance, and trust. In this cloud, our third concept we have to go for Azure, that is core Azure services. And then we go for Azure pricing, and support. Right. These are our objectives that we're going to cover in our complete fundamentals of Azure. So initially, first we'll talk about first concept, that is what is cloud computing. And its vocabularies. Right. So if you talk about cloud computing, although we have various services available in our Azure, right? So if you talk about cloud computing, it is that services provided by the Azure which delivers the model as per the requirement, right? It delivers the model as per the requirement. And what are the models we have? For example, we have storage services. We have storage services. So we have files, we have databases which can be stored in Azure. These are the files, and these are the databases, right? So whenever we are storing structured or unstructured data in a database, it delivers the required services to perform some operations. So there are many services which are available in Azure. So initially we are talking about storage. So storage doesn't only means that we are storing data, but also services and the tools allows you to migrate your data into the cloud. That means although we have our data with us, we have to migrate our data with the cloud. These are the services also provided by the cloud as well. So for migrating the data into the cloud, again the new concept come in the picture, that is compute, or we can say compute power. So for storage, as we know that in our laptop or in our desktop, we have available lots of storage, and that storage required some power. That is, it required some power in the terms of memory, in terms of RAM. So this power is also available in the cloud. So next we talk about computing power. Computing power. To run this computing power, or for the requirement of this computing power, the Azure provide us various resources, which may be Windows, Linux, or web containers. Azure provides us Windows, Linux, or web containers, right? And there are number of 100 services available on the cloud, because the actually cloud is about to create various applications which are maybe AI, ML, web, reporting, etc. So to run all these applications, we require somewhat power, and that power is compute power, and this compute power is provided by the Azure with Windows, Linux, web content, many more, right? Now, once we develop, we have some data to store. For storing data, we require compute power. For that compute power, although we are not about to store a data at a one place, or we want to connect the various services to each other. So again, the next concept come in picture, that is networking. Networking. Now, what we have number of instances, we have number of services we have, and we want to make connection between these services. We have to go for networking, so that we can connect all these services with a secure network, and this data is finally stored in our server or cloud server. So we can say that network provides us or delivers the secure, the cloud delivers us the secure network between those components which we required or which we have some requirement, also develops the secure connection between the data available or the system available in our company. So this all things done by the cloud itself. Now next concept come in picture, that is analytics. Analytics. So what analytics means? Although we have lots of resources and the services available on the cloud, and we are using that resources and services, to know the performance of the services, we have analytics, which shows the performance. We have various graphs. So this shows the performance of our system and our services, so that we can understand that what type of services we are using and how they are performing. So the list of cloud computing is much more larger, but majorly we are discussing here 4 services which are majorly used in our cloud. So if we summarize this thing, we come to know that this is my cloud, and this cloud provides majorly storage, compute power, networking, and analytics. Right? So this is all are the parts of cloud computing. So cloud computing have a certain characteristics that also we have to understand, which are called the key characteristics of the cloud. So what are the cloud key characteristics? The key characteristic of the cloud, number one, first is scalability. Scalability. Number two is elasticity. Number three is agility. Number four is fault tolerance. Five is disaster.
Always do we have PPT for these characteristics, like, or we should note it down?
Sir, I will provide the PPT.
Okay. So I'm not noting. Okay.
Yeah, no need to note, sir.
Yes.
And then we have high availability. So let's understand what are this one by one. So if we talk about scalability, so let us imagine we have a resource. Let us imagine we have a resource, right? This is my resource, or we can call it to be the virtual machine, which we taken it from the cloud. This is my virtual machine, right? And the resource can be of any type of resource we can use, like web application, database, computer VMs, right? So it gives the cloud give us the way that we can scale our resources, or we can increase the size, or we can decrease the size as per the requirement, right? So for example, we have this resource. Now our requirement is high. What we are doing, we are increasing the size of this resource. We are increasing the size of this resource. Now my requirement is increasing. I again increasing the size of resource. So what is this? This is the now what we are using, we are just increasing the size of the resources. See, this is my size, right? So to increase the size, we again required CPU. We have to increase the memory. We have required fast storage, right? So when we are increasing the size of our virtual machine in vertical direction, it is called vertical storage, right? And since we are increasing the size in upper direction, it is called scaling up. And if we are decreasing the size of our virtual machine, it is called scaling down. Right now,
Can we increase the size towards downward also? No, right?
no, we're decreasing. Since we are increasing the size in upper direction, it is called scaling up. Now we are decreasing the size because our requirement is lesser. So since we are decreasing the size, it is called scaling down.
Okay.
Right now, in horizontal direction, we are increasing the quantity or amount of our virtual machine. Initially, I am using one virtual machine. My requirement is more. I am increasing the number of virtual machines rather than increasing the size. So now I'm using two virtual machines. Now my requirement is more. I'm using three virtual machines. So since we are increasing the number of virtual machines, it is called scaling out. This is called scaling out. And if we are decreasing the size, decreasing the number of virtual machines, it is called scaling in. Right? So in vertical direction, we are increasing the size of the virtual machine. In horizontal direction, we are increasing the number of virtual machines. If we increase the size of the virtual machine, it is called scaling up in vertical direction. If we decrease the size of the virtual machine, it is called scaling down. We are increasing the number of virtual machines, it is called scaling out. And if we are decreasing the number of virtual machines, it is called scaling in. So if we summarize, scaling what? Scaling is nothing but it is the ability to scale as per the requirement. And what is this ability to scale? It can be allocating, that is adding, or it can be deallocating, that is removing of our resources. Right? So that is what scalability. Now let us talk about elasticity. What we understand elasticity? Elasticity is nothing but it is a basic concept that we have to understand, that we have a rubber band. If we required, we increase the size. If we required, it can be decrease the size. So elasticity means the ability of our resources which can be scaled up or scaled down dynamically. That is called elasticity. For example, let us understand by a graph, because it may give you good understanding. Right? In x-axis we have time, and on y-axis we have users. Right? So what happened? As per the company requirement, initially we have less usage of the resources, and afterwards there may be a higher usage of resources, and gradually it will decrease as per the requirement. It will decrease. So what we observe at this point, the usage is less. At this point, usage is increasing, and at this is the highest part where we require the highest resources. Right? So what we observe that here we have a single user which is using the resources. So requirement is very, very less. As the number of users increases, the requirement goes on increasing. So it will manage from itself as per the requirement. A requirement is more, the resources will increase its size. A requirement is less, resources itself decrease its size. So from here we can say that here we have a single VM. Here we increase the VM because we have number of users, and here we have more number of users, so we are increasing our virtual machine. So that is what we call it to be the elastic resources. So if we summarize it, we can say that elasticity is the ability to scale dynamically. It is the ability to scale dynamically, right? The next concept we have to understand, agility. Agility. So what is agility is? So in our cloud, there are basically two types of provision to get the resources. Number one is manually, and number two is automatic. That means if we are a user, we are requesting to the cloud that we have that much of requirement and you want to use the resources. So cloud provides the resources. And if we talk about automatic, it will scale up, scale down. It will have a property of elasticity as per the requirement increases. It will automatically add the resources or decrease the resources, right? So likewise, there are two types of availability of the resources for the user. So when we talk about both of this, if we are requesting to get the resource, if we are requesting to get the resource that we want to add some virtual machine, or sometimes we want to reduce our virtual machines. So the time between request submitted and the request available, that is called agility. So what is agility? The time between request has been submitted and response when the request has been fulfilled, that is called agility. That means if we talk about in broader manner, or if we summarize that, we can say that request agility is nothing the ability to react quickly. How our cloud reacting with the user, that is what the ability of agility, right? So the cloud should have a high agility. Talk about cloud should have high agility. So majorly we know about that two types of servers we have cloud and we have on premises. Cloud servers, we know that. And what is on premises? The constant capacity of servers available in our company, that is called on premises, right? So if we talk about the agility with respect to cloud and respect to on premises, so when we put a request in a cloud, it will respond very fast. It may take seconds, it may take minutes if our request is large, it may take hours. But if we talk about on premises, if you put a request to facilitate with a large more number of servers, or we have to reduce the servers, it may take long time, maybe it may take day, it may take weeks, and it may take months, right? That is why we are moving toward the cloud, because the cloud having a fast performance and it has a high agility, scalability, elasticity. So what is agility is, it is the allocating and deallocating the resources quickly. So we can say that ability to react quickly. It is nothing but is the allocation and deallocation of resources quickly. Quickly, right? Now, next we have fault tolerance. What fault tolerance is? Let us we are a user. We are using cloud, and this provide many services. For example, it provides web services, it provide virtual machines, and we are getting it, that is SQL or database, right? So what happened? All these are stored in a server, cloud server. This is my cloud server. This is my cloud server, right? And this cloud server are stored in our data center. This is my complete data center. This is my data center, and we have all the servers in our data center. Now what will happen if there is any component failure? If there is any component failure, then what will happen? The data stored in our server, our data is moved to the another server, so that our data cannot be get deleted from the main server. Similarly, we have a data center. If there is any failure in our data center because of anything, this data move to our another data center. So in our India, we have number of data centers. In all over the world, we have different types of data centers of Microsoft Azure, so that the data can be stored at a various place, so that the data of the customer cannot be get deleted. So we can say that basically fault tolerance is the ability to remain up and running during running the component and its services during the failure. And this may happen due to the localized failures. What are the localized failures? It can be human error, it can be any type of disaster, it can be any type of earthquake, etc., etc. Now next we have disaster recovery. Disaster recovery, it is same as we talked about in our fault tolerance. So although we have, this is my server where we are using web, we are using SQL, right? And this is stored somewhere in our country or in the anywhere in the earth. This is my data center, and this is my another data center, right? So what happened? This is my services which are stored in this data center, right? Now what is happened if there is any local disaster So what will happen? This data can be deleted or removed. So for the sake of security or for the sake of recovery, my same data is stored in another data center also, so that at any point of time, if there is any issue, the data can be used, or our user can redirect. This is my user, initially he using this data, but if there is any disaster, if there is anything happen with this data not working our resources, then the user is redirect to the another copy of our data, which can be replication of our
Bhavesh,
actual
how
data.
many copies are there? How many copies are there?
Sir, they are putting 3 copies at different
Okay.
data centers.
Okay. Means at the same, let's say there is a, like in past you have seen that Sri Lanka is having some issues, Afghanistan is like if we will keep the same in the same country, then it may be a problem for the data center.
Exactly, it may be a problem for the data center. So what they are
So
doing, they are just distributing the data to the various data centers, so that if there is some issue with that country, the data will be our data is safe at that particular country.
hmm.
Yeah.
So they have like different countries, right?
Yeah,
They are
yeah, yeah,
storing
yeah,
it in different countries.
yeah.
But I don't think like if we like, are you talking about Azure, like entire Azure, or it is actually it is owned by Azure, Microsoft, right? So
Yeah,
Microsoft will have these centers, right?
yeah,
So as a company, we just utilize these resources, right?
yeah, we can use it, but majorly what yeah, we can utilize the resources, but if we are sitting in India, right,
Hmm.
so we are most probably try to refer the data center which is nearest to us.
Okay.
Yeah.
For the
Once,
faster processing,
yeah,
right?
exactly, it may reduce the latency, so that for fast process we can prefer this. But more or less we are preferring the India, but they are replicating our data at some another country. If there is a problem with some particular data center, then we can use that data also, which is stored in another country. It may
So
take some
reading
time.
and writing, there are two things, right? Writing may take some time. In that case, if we are writing the same data set to another country, and let's say we are referring the how writing is happening, what is the structure, I mean, architecture for writing?
Actually, so what they are doing, they are using DNS.
Hmm.
They are using DNS. With the help of this, the data, when it is not working, it will redirect our user to the replicated resources, so that we can use it.
Okay.
Likewise.
Okay. Thank you.
Yeah. So if we summarize this, we can say that disaster recovery is the ability to recover from an event that has taken down the server. So this is called disaster recovery. Now we talk about high availability. High availability. Basically, high availability is a simple metric which measures how much uptime of the system can be taken and what is our downtime. So that is shows the what is the availability of our resources, right? So in a general, if we talk about availability, basically it is the ratio of uptime to the uptime plus downtime. So as a user, what we want there should be a minimum downtime for our resources. So if we plot a matrix for this, we have availability, and it can be divided into categories: years, month, and day. So although this is the ratio, so more or less we are, since we can observe that uptime, if uptime is higher, and the total, this term is having some number, and if we are adding downtime with uptime, this denominator will increase, and although the ratio of this availability is become less than 1, it will be less than 1. So we can define availability in terms of percentage, right? So if we talk about availability, that is the system is 99% available, then we can say that its downtime will be 3.64 days if we are using cloud. If talk about in month wise, it will be 7.31 hours in a month, and in a day its downtime is 4.4 minutes. If the availability is 99.9%, then its downtime will decrease, so it will be 7.77 hours, it will be 43.83 minutes. In a month it will be down, and in a day it will be 1.44 minutes. And if we are moving towards the high availability, 99.99% availability, so downtime will decrease, it will be 52.60 minutes per year. Downtime will be 4.38 minutes in a month, and it will be 8.64 seconds. So as we know that as per the major thing is that if we require a high availability, it may require more cost. So it depends on the user what type of availability he want to utilize and on the cloud. So as we change the percentage of the availability, the costing will increase. So if we are using some critical system, then there may be, we cannot tolerate this availability or downtime, so we can go for 99.9% of availability. So it depends on the users, so what type of availability that we are using, right? Now, so these are all the basic terminologies and the vocabularies of the cloud. Now we try to understand that what is the principle of economy, because majorly we are, for as a data engineer, we are already playing with the data with Azure or on a cloud, but also we have to focus on the economics, that what type of architecture we will design so that it requires a minimum cost. So we have to understand what is the principle of economy of scale.
Sir, do we have, means, are we getting charged for this selecting the availability also?
Yeah,
Okay.
actually whatever the resources you are using on cloud, it is chargeable.
Okay.
Right.
I have one more question.
Yeah.
From the agility,
Yeah.
in which we have used the two type of manual and automatic systems, right? So how do the user will know whether we need the manual one or automatic? Or what is the difference between manual and automatic?
Manual one is something like this, that we are, for example, you want to purchase a computer, right? You want to purchase a laptop. So what is your requirement? Your requirement is, for example, your requirement is 16 GB RAM. You are going and purchasing the laptop of 16 GB, right? My requirement is 8 GB. I am purchasing its 8 GB, right? Now my requirement is now my system design is constant, and your system design is also constant. Now what happens if I want to increase my RAM up to 60%? It is not possible for me. Right. So although what I have to do, I have to go to the computer shop and I ask them by increase my RAM up to 16. So what they do, they increase the RAM manually by their own, because I am, as a user, I am requesting them. Right. So This is called manual. And if you talk about automatic, what will happen? As my requirement is increasing, the system will understand, the cloud will understand, that the Microsoft Azure will understand that my requirement is increasing. Now it will automatically add the RAM to my resource, and I'm start working on that.
But it should have that particular number of RAM, right? If you are having 8 GB RAM and you want to get switched to 16, so
Yeah.
it should have 16 GB RAM, right?
Yeah.
Then only it will go to, means do it automatically.
Yeah. Yeah.
If it doesn't have, then we have to go for manually, right?
Yeah. Now actually we have cloud. Understand? We have cloud, right? So cloud has lots of resources with it, right? So as a user, what we want, my requirement is now initially my initially I have 8 GB, but since we are using cloud, now my requirement is changed to 16 GB. The cloud what will do, it will add 16 GB, it add 8 GB to my resource, right? So now it becomes 16 GB. Now afterward, what will happen, after point of time, my requirement got decreased. Now I don't want the 16 GB of RAM, because I have less number of data which I'm using. So now why should I pay for that much amount of RAM? Right. So after time being, what happens now, initially they are adding this 8 GB. Now the cloud will observe that, okay, automatically it will observe that, okay, the customer is not using that much of GB of RAM, then it will minus 8 GB RAM and send back to the cloud. So now what we are doing, we are just paying for that much amount of resource or that much amount of memory which we are using. That is the beautiful thing with the cloud.
Okay, so this is automatically, right?
Yeah, this is automatically. The cloud will avail the facility that now you are using more. If actually there are some functions, if you activate that functions, that I require the automatic function. So as per, since we are using a large number of data, so we are not able to take a track of that, how much data is adding to our database. So we are doing it automatically. So what, with the help of that automatic function, the cloud will automatically add the memory and your function will be continue properly. Otherwise, what will happen? What will happen? The server will get down. Right? So likewise, it will happen.
So are we going to do this in our practicals?
Yeah, we'll do. Don't worry. We'll do each and everything.
Okay.
Currently, just understand the theory. Once we enter into the actual cloud platform, then you understand each and everything, because without doing practical, we're not able to, get a feel of that.
Sure. Yeah. Thank you.
So now we talk about the economy of scaling. So for example, now again, I am talking the same thing, right? Which we discussed. We want to purchase, for example, take a purchasing of some delivery company. So we have a scale. And we have purchased a car. We purchase 2 cars. We purchase 2 cars, right? Because our requirement is for 2 cars. Now the cost of that car is how much? Each individual car, it will be $10,000 of 2 cars. Since we are using 2 cars, we required maintenance. The cost of maintenance is, for example, it may be $100 for each car. It required insurance. It may be of 500, right? And other cost, which may be of $100, right? So if it providing some service to my customer, so what we are doing, we are putting this everything in a track, and we going to calculate cost per unit. What is my cost per unit? And this come in picture that the cost per unit is $10 for a customer, that we are providing a services, that is delivery services. Now what will happen? On the place of 2 cars, we are using 100 cars. We are using 100 cars. Now what will happen? By purchasing a single car from a showroom, what we'll do, we'll directly contact with the company, and we want 100 cars. So there will be somewhat deduction of the cost. So now my cost become, because of I am purchasing 100 cars, now my cost will reduce up to, we are purchasing bulk, it will become $9,000. Maintenance will be reduced. We are putting some, we are giving some contract to some maintenance services to other company. It will become $90. Insurance will get also reduced because we are putting the bulk insurance, so it will also got reduced, $400, right? And other cost maybe got reduced because we are sharing all this cost, it will become $80. So what will happen at last? What we talk about, the cost per unit, my cost per unit will got reduced without affecting my profit. Now it become $9. One delivery, $9. Now what will happen? So from here, what I want to say, that this is my scale. This is my scale. This is my per unit cost. So if we are using less resources, the cost will more. If we are using more resources, the cost will goes on decreasing. So if we are having a big company, we are using more number of resources from the cloud, it will cost less. So this is the small company. Large company. A small company, the cost will be high. If you're a medium company, we are using medium resources, the cost will be medium. And since we are using a large number of resources, since we are a large company, so the costing of that resources will be go down. It will be lower, right? So that is what the cost or principle of economy of scaling. So we are using here, if we are using more number of resources, the costing will reduces gradually. And if we are using less number of resources, it may cost high, right? And next topic, we have the next terminology that we have to understand, that is capital expenditure and operational expenditure. In which we are using a shortcut, that is capex and opex, right? So we'll discuss this in our next class, that is on tomorrow. Any doubt?
No.
Please share the documents if you want to share. Okay.
Sure, sir. I'll share it.
So if you want to, Divya, can you please ping him your mail ID, or let me make a group, okay, so that we can do the sharing order, okay?
Yes, I do much better, sir.
I'll share. I'll create the group.
Okay, fine, sir.
Okay, thank you.
Thank you so much.
Thank you.
Thanks.
Bye bye. Have a
Bye.
good day.